talking about dredging regulation in Brazil and management of contaminated sediments. I have two parts in my presentation. The first one, I am talking about the background of our regulation, and the second one, I will show you some case. One of the case I am going to show, my colleague just present, but on my presentation is just on the environmental monitoring, as we work in this case as the environmental consulting to using the data from your company to present to the environmental agents. So, before 2004, in Brazil, we have no dredging regulation. It was difficult because each environmental agency use a different criterion, or even each technician from the agents or consulting use different criteria. So no pattern, and we use soil Brazilian guidelines or international guidelines, even waste guidelines, to compare with the results from characterization on sediments. And in this time, we didn't, no further studies were done. We just do a chemical analysis in sediments. In 2004, we had published our first dredging regulation, the CONAMA 344. On this regulation, the aquatic disposal decision was based on chemical analysis and toxicity tests, basically metal elements and organic compounds on chemical analysis. In this regulation, we had two action levels, level 1 and 2. These action levels were based on international guidelines, TEL and PEL for freshwater systems, and ERL, ERM for marine and estuarine systems. As these international guidelines are based on field and lab experiments, and these levels are just a first step of on the decision process. In Brazil, we did not develop our own guidelines, so we use the international. So the results from chemical characterization were compared with those two guidelines, two levels. Depends on this comparison. We haven't to do any other investigation, or we follow to toxicity tests as another line of evidence. Generally, the decision was made based on chemical analysis and toxicity tests in this time. In some cases, other studies could be carried on, but it wasn't specified on regulation in that time. So few cases we used to do some another investigations after toxicity tests. Based on these evaluations, the contractor applied for disposal permit to the environmental agents. These disposals could be ocean disposal. This will be the disposal that all the contractors wish to have because it's it's cheaper, or confined disposal. Some examples are CDF or confined aquatic disposal. In 2012, we had revoked our first regulation, dredging regulation, and published our new regulation. The aquatic disposal decision is still based on chemical analysis and toxicity tests, and I'm talking about the main changes we have on this new regulation. The action levels were reviewed based on worldwide dredging guidelines and a Brazilian database. As we have data from 2004 until 2011, we look in our data to compare with our preview guidelines. So we made some changes. For example, arsenium in our national background was higher than former action level 1, so we increased the level because it wasn't every time the level 1 was above, and it was natural. For cadmium and mercury, we had changes as well, because comparing to the worldwide levels. Generally, our action levels were more restrictive than worldwide. In PAH, we included some PAH on the list, and we had included TBT as well. Another change, we clarified that it's not mandatory to analyze the whole list of chemical compounds. It seems to be pretty obvious, but it wasn't in our country. Some agents, environmental agents, or some technicians from consulting thought every time you have to carry on the whole list. It doesn't matter, it doesn't make sense. Based on the site history and according to the environmental agent's decision, you choose the substance to be analyzed. And another change is the definition of significant toxic effect for this regulation. It means toxicity higher than 50% will be considered a significant toxic effect. And the introduction of a dredging characterization unit. It's important to say that this DCU should be defined based on the dredging plan. For example, if I have a dredging plan where I will have a excavation, a 5-meter excavation, I can distribute points on the depth. I will have 1 point each meter plus the surface point. So I will have 6 samples in each point. In this dredging area, I could distribute 5 points. As I have 6 layers for characterization, I will have 30 samples in total. And when I try to do a model to mapping the sediment that's suitable or not suitable for ocean disposal, I can have some gaps once I have some very distant points one from another. So I can use the discrete sampling and increasing points. In this case, I will have a better model to decide if the sediment is suitable or not for ocean disposal. But I will, in this example, have more than 100 samples. Or I can choose the dredging characterization unit. In this example, I have 5 DCU. I distribute the points on this DCU, and in this case, the samples will be composed. So I will have a composed sample for one of these DCUs. As I have the depth, the samples on the depth, I will have a total of 30 composed samples, fewer than the last example, more than 100, and I have a better model to decision the disposal. This sampling method is chosen by the contractor, but should be approved by the environmental agents. So the sampling plan should be approved previously. Another change is if after the characterization and evaluation, the sediments classified as not suitable for ocean disposal based on the 2 lines of evidence, chemical and toxicity tests, the contractor still have a possibility to carry on a complementary studies for applying for ocean disposal. And in this time, this new regulation, these are examples of those complementary studies. Bioaccumulation tests in lab, preferentially in lab, or as an alternative in a field. Sediment alliteration tests carry on in lab as well, or management of the disposal to minimize the impacts, such as controlled disposal, disposal with a diffuser, covering the sediment on disposal area with a better sediment. We have done some of these managements already. And another thing is the introduction, official introduction of the concept of beneficial use of dredging material. As the most dredging materials are clean, we have to start thinking more in beneficial use. So some examples are beach restoration, shore protection, agriculture uses, and other applications. But it's not very used yet because the costs and the privilege of thought that sediments are waste. We still with this thought. So this regulation encourages beneficial use of dredged material and the partnerships between the contractor and universities and public and private institutions. Another change is for the sediment that's going to be inland. So we have some directives for sediment disposal onshore. The results of the chemical results are compared with soil guidelines that are based on risk assessment for different sceneries. And depending on the results and the soil use on the deposition area, these sediments can be used as a hydraulic embankment or disposal on a controlled disposal facility or confined disposal facility. The difference between those facilities are in the first one, the sediment can be disposed directly on soil, and the second one, we need a soil isolation, for example, with a ADP blanket. Another option is the licensed landfill. This is more expensive because I need a dewatering station first. After that, I need the transportation, so it was less used. So the cases I will show you are from southeast of Brazil on the coastal area in here. They are 3 cases. In the first one, the license was given in 2006. The dredging activities began in 2008. The total volume to be dredged is about 4 million. There is still an amount of sediment to be dredged. The sediment volume to ocean disposal is about 3.4, and to be confined 600,000 cubic meters. The technology chosen here is the geotextile tubes. As my colleague already showed you, and as I told, normally the amount to ocean disposal is too higher than to be confined. So we could think in some use for this as well, for this sediment as well. Here are some pictures from the geobags dewatering cells, geobags units being filled, and after the project, final project. So in this case, we had a complementary treatment. After the polymer, we have a complementary treatment station. The effluent had reached the guidelines before being released into the water body, even before this complementary treatment. But as is new technology in Brazil, the environmental agents use a little bit of precaution, prevention, and this complementary station was applied. So after geobags dewatering, the bags were covered, and the area is being used for ship containers. In the second case, the license was given on 2006. Dredging started in 2008, 10, and we still have an amount of sediment to be dredged as well. The total license volume is around 2.5 million cubic meters. The sediment volume for ocean disposal is around 1 million cubic meters. The sediment confined is around 500,000 cubic meters. The technology in this case is CDF. The CDF was constructed in an area near the dredging site to work. The total area is 410,000 square meters, including the outside berm, and the effluent treatment station. The dikes are about 2.4 meters, and the sediment deposit height nowadays are about 2 meters. So we have 5 cells. The cells were filled sequentially. The dredging here were hydraulic dredging, and it was pumped into the cell. As I finish the first one, beginning the second one, and so on. And in this cell, I can have this sedimentation and water clarification process. It was used as a lagoon as well, as I have the sequentially. After that, the water, clarified water, was drained to the treatment station, where I had I add a reagent to absorb the particle that could be in here, and some contaminants. The water body disposal treated effluent reached the guidelines for the effluent and the water quality as well. Here are some pictures for this case: the field lab, the reagent dosage, and a panoramic view of the effluent treatment station. The third case is a recently case, so in this case we use the new regulation. The environmental license was given in 2013. The dredging activities beginning the last year. The total license volume to be dredged is around 1.5 million cubic meters. Sediment volumes for ocean disposal is around 1 million, and to disposal on shore are around 500,000 cubic meters. As we use the new regulation, we compare the results of these sediments with soil guidelines, and we split this volume into two different kinds of confinement. The controlled disposal facility gets 400,000 cubic meter, and the confinal 100,000 cubic meter. The difference between these facilities will be no isolation or isolation from soil. In this case, the isolation is with a double HDPE blanket. In both cases, we have no contact with the groundwater. And it's important to say, in this case, the contractor chose to use geotextile bags to reduce the disposal time and the watering time. It wasn't mandatory from the environmental agents. It was a choice from the contractor. In this case, we have an additional treatment as well after the polymer add for metals and pH. But the effluent has been in compliance with guidelines even without the complementary treatment, just with the polymer. Here is a picture from the treated effluent. It's a pretty clear water. Contaminants in sediment, in this case and in the first case and the second, were PAH and mercury. As these contaminants used to be complexed or absorbed on sediments, on particles, I don't expect to have this after the treatment, the first treatment, I mean, with the polymer, because it will be stay on the solid phase, won't stay on the water after the polymer addition. So, and we are looking for this just on the monitoring. The major issue in this case, and in the first one, the second one, were the nitrogen ammoniacal. So the treatment in here will be increase the pH and aeration to eliminate the nitrogen. Here are some examples of monitoring of CDFs or controlled disposal facilities. Geotechnical monitoring to evaluate stability, isolation, and drainage process. a groundwater monitoring to evaluate the isolation as well. If I will have any contaminant going from the sediment to groundwater, if my isolation is okay. We used to have wells installed around the CDFs. In this case, in Baport, we still monitoring the groundwater to check it, and it's okay. And we monitor as well the effluent, treated effluent, and the water body to check if the guidelines for effluent and quality of water is being reached. For all that sediment, in that case, that won't be confined or controlled disposal, they are going to ocean disposal area. In this case, this ocean disposal is managed by CODESP, that is a port authority in the state of São Paulo. This area is 20 miles from coast, and we have a 10 squares, 2 by 2 kilometers with one. And here we have a control area. This area is licensed by federal environmental agents, and CODESP manages the disposal among several contractors and is responsible for monitoring to the federal environmental agents. This monitoring program includes monthly, quarterly, and semi-annually monitoring. We used to do metals and organic compounds, grain size, toxicity tests, include bench community in quarterly monitoring, and the whole list of our regulation. And semi-annually, we include chemical analysis in tissue of organisms. Even if we have no direct relationship between the dredging and the bioaccumulation on fish, for example, it's an environmental agent's requirement. All 10 squares and surrounding are monitoring. Another monitoring is bathymetry to evaluate the sedimental accumulation, and the management of this area will be based on chemical analysis and toxicity tests, and depends on the results and frequency of those results. The dredging disposal must be changing among the squares, or even stop dredging in extreme case. So that's it. I hope you could understand me. Thank you for your attention.